Okay, so now let's look at this infinite series here. So first thing I notice, and you might notice too, or maybe not, but if you notice that the top number is 1, it's a constant, and then you've got something that's dependent on n. So it seems like that this thing, as far as what you're adding, it seems like you're going to be adding on something smaller and smaller and smaller as n progresses from 1 to infinity. So you're constantly adding something, but you're adding something smaller. So the amount that you're adding to each term is getting smaller. So I would suspect that this thing is probably going to converge, but let's see, okay? Again, just a little bit of gut check there. Maybe, maybe not, okay? So now, let's look at what the partial sums gives us, okay? So S of 1 is what? Well, this is going to be 1/2, right? Okay, because we got 1 times 2. Okay, so let's do S of 2. S of 2 is going to be 1/2 plus what? Well, at 2 you got 1 what? Well, this is 2 times 3, which is 6, right? And if you add those up, we get 2/3. S of 3 is going to give us 1/2 plus 1/6 plus what? Well, 3 times 4 is 12, so it's going to be 1/12. Okay, and so this is going to be what? 2/3 plus a 12th, which is going to give us 3/4. And then if we keep going, let's do S of 4. And of course, this is going to be 1/2 plus 1/6 plus 1/12 plus then 4 times 5 is 20, so it's going to be 1/20. Okay, and this is going to give us 4/5. Okay, and if we could see the pattern, right? So this is going from 2 to 6. This is plus 4, then plus 6, then plus 8, and then plus 10 is going to give us S of 6, or excuse me, S of 5. So this is going to be 1/2 plus 1/6 plus 1/12 plus 1/20 plus 1/30. Okay, and so this is going to give us 5/6. So you can see the pattern in the sequence. So you can see the pattern in the sum, but you can also see the pattern in the sequence. So if you look at the sequence of S of k, what do we get? We got this is 1/2. And then it becomes 2/3, 3/4, 4/5, 5/6, and so on. Okay? Now, looking at this pattern, looking at the sequence of partial sums, we can represent this as an nth term, right? We can write this as a formula. So we can write this as one of those nth term formulas. So we can write this sequence as k over k plus 1, right? Because each term on the bottom is 1 more than the number on the numerator, right? So we can represent the nth term, right? S of k equals to k equals k plus 1. And so we can look at the limit of this thing, right? And so since the limit of this thing as k approaches infinity, right, we see that k over k plus 1 approaches what? Approaches 1 as k goes to infinity. And therefore, we can conclude that the sequence of partial sums converges, and therefore the infinite series converges to 1. So therefore, the series n equals 1 to infinity of 1 over n times n plus 1 equals 1, converges to 1. It converges and it converges to 1. Have a great day.